Hey there! Turn on your speakers. Do you have finals week coming up? Projects due? Homeworks are piling up? Are you freaking out that you're getting boxed in with deadlines? Here's an idea. Get help. Think Geek Exams. Find us on Facebook, Twitter, or YouTube.
So this is the second question in the fifth homework of statics, and here we have a slider on a smooth bar, and its weight is 227 kilograms, and the smooth bar is attached to points A and B, and the coordinates of those points are given, and there's a point C from which a string is holding on to the slider. The slider is at point D, which is at the midpoint of A and B. Then we're told to find the tension on the string, and we're also told to find the normal force, the vector that is acting on the slider from the smooth bar. And also we're told to find the magnitude of the normal force and the direction angles of the normal force. So let's start putting in our coordinates. They are 5, 2, 4 for A, and I'm going to convert them into column vectors, and B is 5, 2, minus 2, and column vector, and C is 0, 7.4, and 7, and convert this to a column vector, and D is A plus B divided by 2, and that needs to be in parentheses, so that should give us the points that we need. Now to get the vectors that are the vector directions that are operating on the slider at D. So DC is the string direction, so it's going to be C minus D, and the normal, the D normal is going to be negative DC, but D normal, the third dimension, the Z dimension, has to be equal to 0. So and dB equals to D minus D. Alright, so these are the directions. UDC equals to DC divided by norm of DC. And that's correct. And U norm equals to D norm divided by norm of D norm, and that's correct. And the third one is weight. Now this one is this one's going to be 0, 0 minus 1. Let's do this in the vector form, and then we have the weight is 227 times 9.81 times this. This is our weight. So the U vector is going to be U. So with U matrix is going to be UDC, U norm, and weight. These are the forces that are. These are the directions of the forces. Let's look at that. Okay, so at this point these are three equations, and if you multiply these with the tension for the first one, the normal force for the second one, and because this is the weight, I don't need to do anything to it. I have to multiply that by 1. So if you multiply these that way, then the resultant vector is going to be 0, 0, 0. So to solve this, let's first solve for the tension. Tension is going to be negative of this number divided by this number. So negative W of 3 divided by U dc of 3. And that should give us our tension. Tension is 3.524.1 actually. So this is in newtons, and times 10 to the power 3 makes it kilonewtons. Yeah, so that's the 1,000. So I just multiplied that 1,000 out. So now that we have t here, so t times this amount and n times this amount is equals to 0. So if we wanted to find t would be, sorry, if we wanted to find n would be u dc 2 times t divided by negative u norm 2. And that is 2.731.4. So that's this number, 2731.4. Now we need to find the vector form. Vector form is nothing but n times u norm. So that should give me the vector for, yeah, so that's this vector over here. It's 1855.7. in vector form is I minus 2004.2 J. And there's okay. And we need to find the angle. So the n angle equals to, let's convert the angle to and then to degrees, and then we basically get a cosine of u norm. So u norm has the cosines of the angles. We find the arc cosines of those numbers. That'll give us radians, and this converts these radians into degrees, and that gives us this is not correct. This is correct. So we were converting to the degrees wrong over there. So now we fix that. This is 47.2026 degrees, 137.2026 degrees, and 90 degrees, and those should be correct. Let's test this out, and all of the answers are correct. So thank you. This ends this transmission. I'll see you next time.
Think Geek Exams. Our agents have Masters of Engineering degrees from MIT, Stanford, Georgia Tech, Caltech. We give you solutions to mathematics, physics, computing, and engineering. Find us on Facebook, Twitter, or YouTube.